Alright, so the learning target today is can the student find an inverse function? The different pieces that we want to look at, these would be our criteria for success. Do you understand the notation? Do you understand what inverse functions do, which is to say their relationship, okay? Like, how are they related? Because when I talk about inverse functions, I'm talking about two different functions that are related somehow. And then the doing part. Can you actually create the function? Or the pair of functions. Okay, we're going to start out with something very simple. The definition of an inverse function, does anyone know this already? Okay, so I know you guys know what the word function means. And I know you know what an inverse operation is. What is the inverse operation of addition, Sam? What's the subtraction, right? Because inverse operation is going to do what? What's the relationship there? Matt?
Is it like the opposite?
Sort of like the opposite. And in most cases, saying the opposite is actually okay. But you want to focus on the word inverse. It undoes. Okay? So when we have an inverse operation, it undoes the first operation. So subtraction undoes addition, multiplication undoes division, roots undo exponents, things like that. This isn't just one operation, it's a whole function. So an inverse function undoes what the first function did. So it's the undoing, and so if I undo something, I should end up back at the original number that I put in. Okay? So the way that looks is, let's say we have f of x equals 2x minus 8. If f of x equals 2x minus 8, then what you have is a function where you're doing what to x? Two things. One, you're multiplying by 2, and second, you are subtracting 8. So if you think of it like this, if I wanted to, if this is f of x, our notation for the inverse function will be f negative 1 of x. Okay? So the notation, guys, is f to the negative 1. Does the negative 1 come after the x? No, it comes in between the f and the x. Okay? So that's our notation. That's that part right there. So it's just a very simple, do I recognize what it means when it says f negative 1, almost like a power, of x? Pick a number, any number, let's say
6.
6. So if I put in 6 to f of x, I am going to take it and I'm going to do 2 times 6 minus 8. 2 times 6 is 12 minus 8 is 4. So you're right there. Now, how do we get 4? What do you think we want in the end?
6.
We want 6. We want to undo what we did in this box and get 6. How do we undo that? Okay? Think about what you did. First you multiplied by 2, and then you subtracted 8. So if I'm going to undo those, the first thing I have to undo is to take x and add 8. So if I take 4 plus 8, I'm at 12. And then I need to divide by 2. That would give me 6. So the inverse function becomes f negative 1 of x equals x plus 8 over 2. And so there's lots of different ways to think about this. I always, you can start with this picture of the boxes like, oh, I put in a 6, I got out a 4, how do I make a 4? 6 again, there. Okay, using the steps, the inverse steps in opposite order. So you guys know addition is the inverse of subtraction. So whenever I see subtraction, I need to do addition. Whenever I see addition, I need to do subtraction. Alright, so let's look at another example. Let's say g of x equals x squared plus 3. If I have g of x equaling x squared plus 3, what is g negative 1 of x? Well, another way you can think about this, guys, is list out your steps. So, what is the first step I'm doing here to x? If I put a number in for x, what's the first thing I would do?
Square.
I would square it. So step 1 was square. Step 2 was add 3. Square it, add 3. If I put a number in for x, that's what you would do. In order to create the inverse function, you need to do inverse operations in opposite order. So we have, what's the inverse operation of squaring? Well, that would be square rooting. The inverse here would be subtract 3. So the way to create the inverse function is to reverse the order. I'm going to take step 2 and make it the first thing I do, right? I'm just going to leave a 2 there so it coincides there. And so the first thing I have to do to create it is subtract 3. The second thing I have to do is square root. And so what we have here, I put my x, and the first thing I need to do is subtract 3. The next thing I need to do is square root. The square root needs to go over everything. So, like that. That becomes your inverse operation of x squared plus 3. If you pick a number, any number, let's say the number 2, okay? G of 2 will equal 2 squared plus 3, right? So G of 2 equals 7, right? Now, let's look at our inverse function, and let's say we know G of negative 1 of 7, so the answer here should equal what? the input on our first one. And so we're going to say root 7 minus 3. Okay? 7 minus 3 is 4, square root 4. And it does indeed equal 2. This is the principal square root here. You get into some different stuff that we'll look at tomorrow if you are looking at the negative square root also. Alright, questions on this? No? Let's look at one more. Let's say h of x equals root x plus 1. The two things I'm doing to x here are adding and square rooting. Two things in that order. So the first thing I'm going to do when I create h of negative 1 is square it. Because the first thing I'm doing here is adding 1. The second thing is square root. So the inverse will be step 2, inverse of that. So we're going to square. And the last thing we need to do to it, the second step in the inverse becomes subtract 1. As I look at that, okay, so I write my x, I do the first thing I need to, and then I subtract 1. Those will be your inverse operations. So we did look at notation. We've got our negative 1 to represent the inverse function. What does an inverse function do? Well, it undoes what the first function did. And then creating the pair, we have two different ways to look at it right now. We can either use the boxes that we used on the first example, or we can create a list of steps of things we are doing to x, and then use the inverse operations in the opposite order to create the steps on your inverse function.